So what the tool's done is it's taken that view state, it's decoded it, it's embedded the malicious attack into the view state and encoded it again. So I'm going to copy that and what I will do next is simulate a post back. So now instead of having proxies and intercepting requests and so on, we just created a simple form just to kind of expedite this demo. And this will submit this attack view state to the thank you page again. And remember this, now the application will think this is a post back because it's, it's got the view state in it. And let's see. Okay, so there's a number of things on this page. But the ones we're looking for are this credit card number right here. So here's the credit card number. And here's a security code. As you can see, security code, credit card number. And the way this was obtained was it was everything that was in session, that the application put into session is now being printed out here. It also has everything that's in application scope. So it has the database, this application would persist, for example, this credit card, would probably persist in a database. And it's typical for applications to, put connection pools and things that are required by the entire application into application scope. So the database user and the password is right there. So this is the password. These are the credentials for for the database credentials essentially. So again, these are things that applications put into session, into application scope, and you never would think that you'd be able to access this using a client-side attack. And because this view state has not been encrypted, and because this attack can be embedded into the view state, you can access that kind of information. So you're next.
Okay. Okay, so as Rahi had showed you earlier, the tool helps break down the internal structure of the view state. It's normally just, by default, it's included in the HTML as a base64 encoded gzipped Java object stream. So it's not extremely easy to read manually. When it's decoded, you can see the different components. And I don't want to get into this a whole lot, but it's easy to see how this happened when you start looking at the source code. Oh, I thought it was going to be highlighted. All right, so basically this is the function that takes the view state provided by the client and handles it. Unlike ASP view state, in Java server faces, as we mentioned earlier, the view state is the actual serialized object that is handled on the server. And when the view state is restored on the server side, it recursively traverses the tree, reinstantiates each object in that stream back on the server, so that what you can, in theory, although it's a very difficult attack to launch, which is why it's not in our tool, but in theory you can provide any kind of Java object back to the server just by modifying the view state. The simplest way of demonstrating that in a proof of concept, which is what we did in Deface, is just to target the expression language objects. And so what Deface does is it traverses whatever view state you provide for it, looks for the expression languages and replaces it, like where he was talking about earlier. Back to
Right. So this is the ASP.NET view state lifecycle. So we're moving on to .NET at this point. So remember, .NET does not put the entire UI control hierarchy into the view state. It just puts the changes that it needs to remember, things that are, say controls are added programmatically and are not static. That kind of information is put into the view state. So on initial browser request, this class is auto-generated, and the page control hierarchy is also created programmatically. Now, it receives a post back, it loads the view state, and it populates the control hierarchy with the view state data. So this is the data that the controls need to remember in order to preserve their state. It also validates that data for tampering. Then again, very much like the Java server faces lifecycle, it loads the request data from the object or from the request. And it also checks, it basically goes through the control hierarchy and sees if they implement the iPostBack data handler interface. And so if they're interested in that, in the data, passes the value to the server control to update the state. So you've got updated control hierarchy. The page load event is fired, very familiar to .NET developers. Now you've got updated view state, a control hierarchy. You're ready to save the state. Recursively calls that control hierarchy and checks if any of those components are interested in saving their state by invoking the save view state method. Constructs the page view state, serializes to a base 64 encoded string, and places it in a hidden field, _view state. Again, this does not have to be put into this hidden field. That's just how it's commonly done. It can be kept on the server as well. And then you're ready to generate the web page.
Okay, so the demonstration environment for ASP.NET is a lot simpler. It's Windows Server 2008 R2. It was supposed to be ASP.NET 3.5. It's actually 2.0, but it'll work exactly the same. I think actually the code that's impacted wasn't changed at all between versions. This is the HTML that's used, or excuse me, the ASP that's used. It's a very simple page. You show this to most people, most developers, and ask them to spot the vulnerability. And you know, an astute developer is going to notice that enable view state MAC is set to false, which is counter to the default. Microsoft did it right by enabling view state security by default. But by itself, especially on such a simple page, it doesn't seem that it would be a dangerous thing to do. I mean, basically you just have HTML and a form tag. And by the way, the reason that validate request true is on there is to show that it's explicitly set. The validate request has to do with some security controls in ASP to detect, among other things, cross-site scripting. The attack that we're going to be demonstrating is cross-site scripting, so it's explicitly enabled to show that functionality does not protect against this attack, which is not all that surprising because that's not really what validate request was intended to stop. So, go over. Now, we didn't write a tool for this, mostly just, I guess because it's hard, but if we go to the first example for .NET, it's a blank page, which makes sense because there wasn't anything on there, it was just a form tag. If we look at the source code, we see that the form tag was expanded by the server, and several attributes were added that are part of .NET. It set the method to the default. It also added a hidden input field for view state. It's very small. We can take a look at it real quick. For anyone that works much with .NET, especially if you're doing security work with it, I highly recommend View State Hacker. It's basically a tool to help decode view state. Essentially, the format of view state is base 64, of course, you can probably tell by default, but under the base 64, it's basically a binary version of XML, so there's a lot of plain text strings in there. You can usually get the gist of it just by the plain decode, but View State Hacker puts everything back into its proper hierarchy. The view state's basically empty. The only thing that's in there, and this is normal for a simple page, is a single value that's a number, and I forgot to look this up. I always forget what this is for. It has to do with basically a serial number. It's not for security or anything like that, but we can basically ignore it. So let's go back to the page. And this time I'm going to go to a different request. Now, you see that there's obviously some cross-site scripting going on here. And what we can do is copy the view state that was from the example. And I'm not going to demonstrate building this because it's kind of a pain in the neck without a tool. So I just built it ahead of time, basically, and we'll show you how it breaks down. So if we decode it, we still have the same serial number there as before, but some other data has been added. Now, the core of the data is a pair, so basically name value, type of thing you would see in a collection, which is actually what it's a member of. The name of it is inner HTML, and the string is pretty straightforward cross-site scripting attack. If we go back to the page with the cross-site scripting attack and look at the source, I hit the wrong button, hang on.